So let's continue talking about the center of pressure on an inclined plate. So once again, this is our equation from the engineering equation manual. So YCP, the distance from the surface to the center of pressure, is going to be YC, which is the distance from the surface to the center of gravity, is going to plus gamma sine of theta, that's the angle of our plate, IXC. And so what is IXC? Well, that's the moment of inertia of the body along the horizontal axis that's passing through the centroid of the body. You also see this as IXX, divided by the pressure at the center of gravity times the area. So easy enough. So as we're looking at IXX, depending on the shape, you're going to have to go look that up. Once again, there's great tables in that Nice manual, or you can look back in your mechanics book and whatnot. And so what that's going to do is that's going to give us how far along this axis, this y-axis, that the center of pressure slides down. So you may be asking, well, what about in the x direction? Does the force move along the x direction? And the answer to that is it depends. So if I have a circular plate like this, and I know it isn't a very good circle, but let's just say that I drew this as a good circle, and then this side here is the exact same as that side there. So how is this equation different? Well, this equation would be talking about XC, and it would be talking about how far off that X centroid it is. But the real change in the equation, instead of having that IXX or that IXC, we'd have IXY, which is the moment of inertia about that y-axis. And since it's balanced, since it's symmetrical around that side, well, that IXY is going to turn out to be 0. So your x direction shift off the center is going to be 0. It's not going to shift over. And that's basically for any symmetrical plate. We're not really going to be giving you any non-symmetrical plates in here, because as soon as we do that, we add another level of math in there and get beyond just the basics that we're dealing with.